When we look up from our backyards and see the river of light we call the Milky Way, we are witnessing the edge of our cosmic home, a place so vast that its true shape is hidden from us by our own small position within it. Tonight, we step outside that home, if only in imagination, and try to see it whole. From the dark beyond the galaxy, the Milky Way would appear as a barred spiral, a great wheel of stars and gas 400 billion kilometers across, thin as a sheet of cigarette paper in proportion to its width. 100 billion suns ride this wheel, each a potential lantern for worlds we have never touched. They are gathered into sweeping arms that unwind from a bright central bar, glowing like frost on an invisible spiderweb. We ourselves live on a minor spur between two major arms, a quiet backwater called the Orion Cygnus Arm. On a galactic scale, it is an unremarkable ridge. Yet here the night sky is thick with stars because we are embedded among them like dust motes in a shaft of light. To any civilization orbiting a star along a grander arm, our neighborhood would seem sparse, a place where the sky is only half full. Imagine the galaxy pressed flat into a dinner plate 1 meter wide. Our solar system would be a grain of sugar drifting just outside the rim, and the plate itself would be no thicker than a butterfly's wing. Yet within that slender disk orbit enough stars to give every living human 10,000 suns to call their own. The disk is so thin that if a spacecraft could leave Earth at the speed of our fastest planetary probes, it would escape the vertical thickness in a mere million years, a blink against the 12 billion year life of the galaxy. This thinness is no accident. Over eons, the gentle collisions of gas clouds and newborn stars have settled them into a common plane, the way snowflakes settle on a windless day. Above and below, a sparse halo of ancient suns orbits in slow, tilted loops, refugees from an earlier epoch when chaos still ruled. Between them lies a halo of something unseen, holding the spinning disk together by gravity alone, a ghostly scaffolding we have named dark matter because light passes through it untouched. For most of history, we did not know even this shape. 2 centuries ago, William Herschel, surveying the sky with his sister Caroline from their garden in Bath, counted stars in hundreds of small patches, assuming that brighter patches meant deeper star fields. His map resembled a stubby cross, the first crude outline of our flattened system, but he placed the sun near the center, for the dust of interstellar space had hidden the true center from his view. Not until 1918 did Harlow Shapley, mapping globular clusters like distant lighthouses, move us to the margins and reveal that the hub lies tens of thousands of light years away, behind curtains of dust and gas. Today, surveys named after rivers of data, Sloan Gaia, WISE catalog 1 billion stars at a time, measuring each with such precision that we can replay their past trajectories and fast-forward their future dances. We have learned that our barred spiral is still growing, its arms not rigid but patterns that stars enter and exit like surfers on a wave that itself is only water in motion. The bar at the center churns like a slow whisk, stirring gas toward the core, feeding both starbirth and the quiet supermassive black hole that waits there, patient as time. Yet even with all our maps, most of the galaxy remains uncharted. Interstellar dust blocks visible light, so we send infrared eyes above the atmosphere to peer through the haze. Radio telescopes listen to the faint whisper of hydrogen atoms, each emitting a tone 1420 megahertz above silence. By translating that tone into color, we paint the spiral arms in neon blues and greens, revealing where new suns ignite like sparks along a fuse. Still, the spiral is only the luminous froth on a deeper ocean. Beyond the last star, the Milky Way is circled by dozens of lesser galaxies, the large and small Magellanic clouds among them, irregular smudges visible from Earth's southern skies. They are slowly being torn apart by our gravity, their stars drawn into the halo like autumn leaves into a whirlpool. In 4 billion years, the Great Spiral itself will meet its match. The approaching Andromeda Galaxy, another barred spiral larger than our own. The two will drift together, their arms flaring and braiding until they merge into a single elliptical cloud of stars. By then, Earth's oceans will have boiled away, the sun will be swelling toward red gianthood, and any descendants who remember our present night will see a sky ablaze with new constellations, the old constellations dissolved into glowing strata. For now, we remain passengers on a grain of dust orbiting a modest star, ourselves made of dust that once orbited other stars, now briefly organized into minds that can wonder. The Milky Way turns above us once each day, but in galactic time that daily spin is imperceptible. Our fastest rockets would need 100 millennia merely to cross the distance to the nearest star, and 100 million centuries to cross the galaxy. We are small, yet we are also the universe's way of reflecting on itself, a flicker of awareness in a structure so large that light itself takes 100,000 years to cross it. Contemplating this scale can feel like standing at the shore of an endless sea. The waves arrive at our feet with dependable rhythm, yet beyond the horizon the ocean merges with sky, and even the bravest voyager must admit the limit of sight. So it is with our galaxy. We map its arms, weigh its dark matter, time its spin, but always from within, always from a moving perch whose own future path is uncertain. Perhaps one day probes finer than dust will ride laser sails outward, reporting back in whispered pulses. Perhaps one day minds no longer bound to flesh will drift between stars like auroras. Or perhaps the task is enough for us simply to know that we live in a barred spiral of 100 billion suns, that we are held gently between its arms, and that every atom in our bodies has traveled this river of light. For the moment, let us keep that image, a thin disk of stars turning once every 1/4 billion years, carrying us with it unfelt. We cannot step outside to watch, yet we can imagine. And in that imagining, we prepare ourselves for the next widening of the lens, the next retreat that will place our entire island universe among other islands, scattered like frost across the cosmic dark. To feel the size of anything, we first need a place to stand. On Earth, we gauge distance with the length of a stride, the reach of an arm, the horizon that swallows a setting sun. But hoisted into space, the same instincts dissolve. The moon, a silver coin overhead, hangs 400,000 kilometers away, 10 times the girth of our planet, yet close enough for mirrors left by astronauts to bounce back a laser's kiss. Shift your gaze to Venus when it gleams at dusk, and you are peering across a gulf 100 times wider. Keep lifting your eyes, and soon the kilometers themselves lose meaning. We speak instead in light years. The distance a ray of light glides in the dark for 12 long months. 9 trillion kilometers of travel packed into a single, effortless breath. For millennia, humanity had no way to know whether the stars were near or infinitely far. The sky looked like a dome, a velvet ceiling studded with sparks. Then, in the early 19th century, an astronomer named Friedrich Bessel noticed a nearby star shifting its place against the distant backdrop as Earth moved from one side of the sun to the other. The shift was tiny, smaller than the apparent width of a penny viewed from 16 kilometers away, but it was enough. Geometry, the most ancient of sciences, had reached across space. Using the width of Earth's orbit as a baseline, astronomers could now triangulate the distance to nearby stars the way surveyors map a forest. They called the method parallax, and it became the first reliable rung on a ladder that would eventually climb to the edge of the observable universe. Yet even the widest baseline our planet provides is puny on the scale of the galaxy. Parallax can measure the neighborhood, but the great star cities of the Milky Way lie thousands of light years distant. At such remove, the apparent wink of a star becomes too small for Earth's orbit to reveal. We needed a longer yardstick, one not rooted in kilometers but in the intrinsic brightness of the stars themselves. Some stars pulse like heartbeats. Their surfaces swell and contract, brightening and dimming in rhythms that obey the laws of physics with metronomic fidelity. Cepheid variables, named for the prototype in the constellation Cepheus, are the most luminous of these cosmic beacons. A Cepheid's period of pulsation tells you, with uncanny precision, how much light it emits. Compare that known luminosity with the feeble glow we receive, and the star's distance falls out like solving a simple proportion. A single Cepheid, caught in a spiral arm of a distant galaxy, can betray the galaxy's distance across millions of light years. Closer to home, humbler stars called RR Lyrae tick with similar reliability. They are older dimmer, the elders of the stellar clan. Where Cepheids blaze like searchlights, RR Lyrae twinkle like lanterns in a harbor, guiding us through the congested center of our own galaxy. Together, these standard candles extend our reach outward by a factor of 1,000, yet they too have limits. Beyond a certain range, even the mightiest Cepheid fades into the background glow of the universe. To press farther, astronomers borrowed a trick from spectroscopy. Every star encodes its temperature, mass, and chemical makeup in the rainbow barcode of its light. By spreading that light into a spectrum, we can read the star's story without ever leaving Earth. Knowing the star's temperature and brightness class, we can estimate how much light it truly emits. Compare that intrinsic brightness with the feeble trickle that arrives, and again distance emerges from simple ratios. The method is called spectroscopic parallax, a name that sounds like a contradiction. No triangles are drawn, no apparent shift is measured. Yet it carries our yardstick out to tens of thousands of light years, far enough to glimpse the edges of the galactic disk. Still, every step up this ladder inherits the uncertainties of the rung below. A tremble at the base amplifies at the summit. By the late 20th century, our best maps of the Milky Way carried error bars wide enough to swallow whole star clusters. We needed a cleaner anchor, a measuring tape suspended not from Earth but from space itself. In 2013, the European Space Agency launched Gaia, a pair of telescopes perched 1 million miles sunward of Earth. For years, the craft has spun slowly, sweeping the sky with gigapixels of frozen starlight. Gaia measures positions with the precision of a person in Paris reading the embroidery on a flag in New York. It records parallaxes for more than 1 billion stars, extending the classical triangle method 1,000 times farther than any ground-based telescope. The resulting catalog is less like a map and more like a living census, charting who drifts toward us, who recedes, who orbits an invisible companion, who sails alone. Yet even Gaia confronts the same ancient enemy, distance itself. Beyond a few tens of thousands of light years, parallax once again becomes unreadable. The galaxy spans 100,000 light years across, its spiral arms wrapped like silver ribbons around a central bulge dense with stars and dust. To weigh the whole, we must rely on the same candles and spectroscopic inferences that humbled earlier explorers. Each method passes the baton to the next, forming a cosmic distance ladder whose rungs are stitched together by physics, but whose nails and braces are still human judgment. Consider the uncertainty. A Cepheid's luminosity depends on the metallicity of its surroundings, how much carbon, nitrogen, and oxygen pervade the gas from which it formed. Correct for that, and another wrinkle appears. Interstellar dust, fine as smoke, can dim starlight by unpredictable degrees. Correct for dust, and we must still ask whether Cepheids in the crowded core of a galaxy behave exactly like their cousins in the quiet outskirts. Each assumption is small, but they accumulate like grains of sand until the edge of our knowledge resembles a coastline blurred by fog. Even so, the ladder stands. Astronomers speak of a distance modulus, a logarithmic shorthand that compresses factors of 10 into simple numbers. They quote errors of 5, 7, 10%, sounding precise, yet those percentages translate to uncertainties of thousands of light years when applied to the far side of the galaxy. We know the Milky Way's center lies 26,000 light years away. Give or take a few hundred, a margin narrower than a decade ago but still wide enough to lose entire civilizations in. What does it mean to live inside a structure whose dimensions we cannot measure exactly? Perhaps it is akin to waking within a cathedral at night, feeling the columns rise beyond the reach of your lantern, sensing vaults too high to glimpse. You map by echo, by faint echoes of light. Every star is a clapper striking the bell of space, and the returning sound, diminished, shifted, stretched, tells you how far the walls must stand. We will never pace the galaxy with footsteps, never reel it in like rope. Instead, we measure by inference built upon inference, trusting that the laws of physics discovered in terrestrial laboratories still hold in the unvisited void. So far, that trust repays us. The same gravity that guides a thrown ball arcs star clusters around the galactic center. The same nuclear fusion that warms Earth powers Cepheid hearts. The same quantum mechanics that lights a neon sign carves the absorption lines we read across parsecs of emptiness. Yet mysteries remain. Dark matter, invisible and vast, drapes the Milky Way in a halo whose radius we infer only from the motions of tracer stars. How far does the halo extend? Twice the visible disk, 10 times. No standard candle reaches that far. We extrapolate hesitantly like sailors who hear surf in the dark and guess the distance to shore. And beyond our island of stars, other galaxies drift in a sea of expanding space. Their distances await the next extension of the ladder, type Ia supernovae, the titans that briefly outshine their host galaxies. But that is another chapter, another climb. For now, we remain within the Milky Way, charting our home. To stand beneath a dark rural sky is to see the glow of billions of unresolved suns merged into a river of light. Each photon has traveled for eons, threading the gaps between stars, sliding past dust clouds, slipping through the pupil of your eye to end its journey on the retina of a species young enough to count the millennia on its fingers. The light left its star when saber-toothed cats prowled, or when dinosaurs stamped, or when the Earth itself was still molten. To measure such distances is to hold a thread that stitches your momentary existence to epochs older than any mountain range. We are not small because the universe is large. We are large because we can know it is. A galaxy, 100 billion stars, a trillion planets, perhaps more, wheels silently in the dark, and within it, on a speck of dust orbiting a speck of light, a mind can close one eye, hold up a thumb, and triangulate the span to Alpha Centauri. The same mind, given years of patient observation, can watch a Cepheid pulse and name the distance to another spiral arm where new suns are forging heavy elements that will one day build other minds. Measurement is an act of reverence. Each data point is a quiet tribute to the stability of nature, a promise that what holds true here holds true there, that the universe is not capricious, only vast. We will refine our tools. Gaia's successors will chart fainter stars, and future telescopes will read spectra with such delicacy that the footfalls of planets tugging their suns will become audible. The ladder will grow steadier, higher, more ornate, yet it will still rest on the same rung bezel first set against the sky, the simple geometry of a moving Earth. Until then, we walk in partial knowledge, like cartographers sketching coastlines through drifting mist. We know enough to sense the shape of the galaxy, enough to feel both its grandeur and our belonging. Somewhere in the bulge, stars swarm so thickly that night never falls on any world within their midst. In the outer halo, suns drift alone, their planets seeing only a scattered handful of neighbors across the black. Between those extremes, we find our own orbit, neither center nor edge, a quiet suburb where the sky is dark enough to wonder. To measure is to begin to understand. To understand is to begin to feel at home, even in immensity. The Milky Way turns once every quarter-billion years, a stately rotation that carries us, unfelt, through spiral arms and interarm voids. We ride the rim of a wheel whose circumference we have inferred from the flicker of candles and the subtle shift of nearby beacons. The numbers are imperfect, the errors still large, yet they are ours, written in the same language as the stars themselves. And so we continue, counting heartbeats of variable stars, tracing parallaxes smaller than the width of a hair held at arm's length, trusting that the effort to know is itself a form of arrival. One day, perhaps, a future explorer will stand on a world orbiting a red sun in the Cygnus arm, look toward our own yellow star, and measure the distance back to us with the same quiet certainty we now project outward. The latter will fold back on itself, a circle closed across light years of darkness. Until that moment arrives, or perhaps long after it has, we will keep extending our reach, one careful inference at a time, feeling for the edges of the galaxy we call home, sensing, as we do, the faint tug of something still farther, still unseen, waiting beyond the next rung of light. To feel the true size of the Milky Way's luminous disk, begin with something you already know. Imagine the sun reduced to the head of a pin. Earth, a grain of sand, sits one thumb width away. Neptune, the faint blue speck, orbits 30 paces from the pin. Now walk. Walk until the sand grain under your shoe has circled the pin 6 billion times. That single, slow orbit is 1 light-year across. Keep walking. Walk until you have traced a circle 100,000 of those light-years wide. Only then have you drawn the luminous wheel we call the galactic disk. At this scale, the disk is not a sharp coin. It is a sigh of starlight that fades like breath on winter glass. From the sun's quiet suburb, 30,000 light-years from the center, the brilliance thickens inward, layer upon layer, until the hub glitters like a city scene from an approaching aircraft. Outward, the opposite happens. Stars thin, then scatter, then vanish. There is no fence, no sudden drop into darkness, only a slow surrender to emptiness. Astronomers once drew a neat line at 50,000 light-years, a polite diameter for the luminous part. But the stars themselves did not vote on the boundary. They drift, sparse and old, beyond the line, forming a ragged frontier whose last sentinels can barely keep their fusion fires lit. When we map them, we find the edge is a gradient painted in star counts and silence, a place where the night between neighbors grows wider than the solar system itself. Hold that thought. The solar system, so vast that our fastest craft would need 10,000 years to cross it, becomes a porch step when measured against the thinning of the disk. Between the final stars, gulfs yawn wide enough to park 1,000 planetary systems side by side and still leave room for echoes. Yet those gulfs are inside the galaxy, inside the structure we casually label home. Look deeper and the disk refuses flatness. It bends. Beyond the sun's orbit, the plane of the Milky Way warps like an old phonograph record left too close to a stove. One side lifts, the other dips. The reason is gentle but persistent, the gravitational tug of dwarf galaxies we cannot see directly, only feel through the flexing of star streams. The warp is slow, rising a few hundred light-years every 1,000 light-years of radius. A curvature so subtle that if you could stand on it, the horizon would still feel level to your feet. Across 40,000 light-years, though, the bend becomes a wave taller than the disk is thick, a ripple that carries suns like foam on a dark tide. Thickness, too, tells a quiet story. Where we live, the disk is only 1,000 light-years top to bottom, thinner, proportionally, than a dinner plate. Yet even here, stars bob above and below, elderly stars especially, their orbits inclined like horses on a merry-go-round that has lost its rigidity. Gravity from the spiral arms plucks them up, then lets them fall back, a gentle churning that keeps the edge from looking sharp when seen from far away. Now consider what we do not see. Wrapped around the luminous disk, an ocean of dark matter outweighs every star and cloud of gas by nearly 6 to 1. It does not glow, it does not collide, it only pulls. Its shape is guessed at from the way the outermost stars move faster than they should, held to their paths by an invisible current. Where the starlight ends, the dark halo merely begins. Its boundary is thought to lie 300,000 light-years out, 3 times the diameter of the visible wheel. Thus the Milky Way you picture at night, the spilled sugar of the Milky Way, is only the bright nucleus of a much vaster creature, a jellyfish whose luminous bell is small compared to its dark, surrounding tentacles. So when we speak of size, we must ask, which size? The size of the light we can photograph or the size of the gravity we can feel? The first fits inside a dinner plate scaled to the galaxy. The second needs a banquet table stretching from Los Angeles to London. Both are true, neither is complete. Pause for a moment and let the numbers settle. 100,000 light-years. Light, racing at 600 million miles an hour, needs 100 millennia to cross the disk. When the first light that left the far rim began its journey, our ancestors were just beginning to speak. When that light finally reaches us, we name it star, photograph it, forget it. The galaxy endures, indifferent to the flicker of civilizations that learn to read its light. Yet indifference is not hostility. The very scale that dwarfs us also shelters. Between the stars lie not only voids but possibilities. Supernovae are few enough that life has time to take root. Metals astronomers metal, every atom heavier than helium, are plentiful enough from generations of dead stars to build rocky worlds. The disk is vast, but not so vast that its resources are out of reach. It is old, but not so old that its best sunsets are behind it. We live inside a balance struck by radius and time, a quiet zone where the scale feels almost curated. Still, the eye keeps traveling to the place where star count becomes 0. There, at the perceived edge, the warp lifts the final strands of gas above the plane, exposing them to the harder radiation of intergalactic space. They glow in ultraviolet, ghostly veils stripped of new stars, the last exhale before darkness. Beyond, only the individual outcasts remain, halo stars on plunging orbits, ancient suns flung outward by ancient encounters, carrying with them the heavy elements of worlds that once circled them. They are the galaxy's memory, drifting into night. What does it mean, then, to trace a boundary across something that fades? Perhaps the same as tracing the edge of a memory. You know it ends, but you cannot say exactly where. The Milky Way's disk dissolves not into nothing, but into a question. How far can gravity still call a star back home? The answer is written in speed and distance, in the silent negotiation between kinetic flight and gravitational grip. Some stars win escape, most do not. The edge is the place where the verdict is delivered in barely perceptible motion, a legal system whose courtroom is measured in parsecs and whose trials last eons. Stand outside on the next clear night and look at the band of light overhead. It appears solid, a river of milk, as the ancients said. But every patch of that glow is a vista stretching thousands of light years, depth stacked upon depth until sight itself gives up. The width of that river from horizon to horizon is the width of the disk seen from within. We are inside the wheel, riding it, unable to step back for a full view. Our maps are built from parallaxes and Dopplers, from starlight too faint for the eye, stitched together into a silhouette we will never personally witness. Yet the mind can travel. The mind can walk the 100,000 light years, count the thinning stars, feel the warp rise under its feet, and finally step beyond the light into the surrounding ocean of dark. There, at the outermost reach, where even outcast stars are rare, the disk is no longer a place but a direction. Toward the center, the glow thickens. Away, it thins. You stand on a single cinder of rock orbiting a solitary red dwarf, and every other sun is behind you. Ahead lies only the distant lanterns of other galaxies, themselves disks and spirals, themselves fading into their own edges. Turn back. The Milky Way's disk is now a faint slash across the sky, a line of light so narrow you could hide it behind your outstretched thumb, so long that its photons began traveling when our kind still shared the planet with Neanderthals. Hold that thumb there. You are covering 100 billion suns, 100,000 light years, a structure whose size can be spoken but never fully grasped. And yet, grasping is not the point. The point is relationship. The disk's size is not a trophy number. It is the field across which matter, energy, and time play out their slow game. Its edge is not a wall but a threshold, a place where the galaxy's influence becomes a whisper, where the larger universe begins to listen. We will follow that whisper. We will leave the bright wheel behind and enter the halo, the dark, the streams of stars that orbit like distant moons of a world we thought we knew. Out there, distance is measured not in thousands but in hundreds of thousands of light years, and time moves to an older rhythm. Out there, the Milky Way is no longer a disk you can draw on paper, but a gravity well so wide that even its own globular clusters take 250 million years to fall around at once. Out there, the true scale of our galaxy and of ourselves will come quietly into view. At the heart of every great city lies a plaza no wider than a few cross streets, yet every boulevard and back alley ultimately points toward it. Our galaxy also has such a place. From Earth, it hides behind veils of dust 25,000 light years away, a region so small that, on the sky, it fits behind a grain of rice held at arm's length. But within that rice grain, stars swarm thicker than bees at midsummer, and gravity tightens until time itself slows. This is the galactic center. This is where the Milky Way keeps its deepest secret. Imagine leaving Earth at the speed of the fastest probes we have ever hurled toward the outer planets. For 80,000 years you would fall through darkness, past constellations that slowly rearrange themselves, past the Pleiades, past Orion's lifted arm, past glowing clouds where suns are still being born. Finally, you would drift through a last, thinning layer of dust and emerge above a sky ablaze. Stars here are only light weeks, sometimes light hours apart. Night on a nearby planet would be starlight so bright that shadows would be sharp as noon. Radiation storms of X-rays and gamma rays sweep the void. So any world would need a magnetic cocoon thicker than Earth's entire iron core to keep its atmosphere from being peeled away like paint beneath a blowtorch. This is no place for quiet oceans or drifting continents. This is a forge. At the very core, tucked inside a maze of gas streams and magnetic fields, sits Sagittarius A star. We call it a name, but it is not a thing you could ever touch. It is a region where gravity has won every argument. 4 million times the mass of our sun, yet compressed into a volume no larger than the orbit of Mercury. If you could carry it in your hand, it would weigh more than the mountain you stand upon, more than the continent beneath the mountain. But carry is the wrong verb. It carries you. It carries the entire galaxy. We know it is there because we have seen the dance it commands. For 25 years, astronomers watched a cluster of stars no brighter than pinpricks whirl around an empty point. One of those stars, modestly named S2, completes a full orbit every 16 years, racing through space at 30,000 kilometers each second. If you could stand on its surface, the sky would be a blur, and the central blackness would swell and shrink as you rose and fell. At closest approach, S2 skims the edge of the abyss at a distance no greater than Pluto is from the Sun. There, the fabric of space is so curved that starlight climbing away from the surface is stretched and reddened, a visible bruise of gravity. Newton could never have described such motion. Einstein's equations predict it exactly. Each sweep around the void is a reminder that space and time are not the rigid stage we once believed, but a fabric that can sag and ripple under weight. Yet the black hole itself is strangely quiet. Astronomers speak of quasars, cosmic searchlights powered by black holes eating stars like fruit, and wonder why our own monster glows so faintly. A teaspoon of material falling across its boundary would release enough energy to run human civilization for 1 trillion years, but most days Sagittarius A star merely smolders. Something is choking the feast. Magnetic fields may be twisted into barricades, or the winds of nearby giant stars may blow the food away before it can spiral inward. We do not yet know. The galaxy's heart beats slowly, and we have only just placed our fingers on the pulse. Farther out, the bulge of old stars thickens like a swarm of tired fireflies around a darkened lantern. Here, orbits are not the tidy ellipses of high school textbooks. They weave and braid, tugged by the bar, an elongated river of billions of suns that rotates like a slow propeller at the galaxy's center. The bar stirs the bulge the way a wooden spoon stirs milk into coffee, pulling gas toward the middle, sending stars ricocheting toward the halo. Over billions of years, this invisible stirring has written the spiral arms we see from Earth. Gravity is memory written in motion, and still the black hole grows, not by gorging but by sipping. A wisp of cloud drifts too close, stretches into ribbons, glows like heated iron, and only then does a modest portion slide across the horizon. We have seen flares, bright flashes in infrared and X-ray when this happens. Each flare is the echo of a meal, a reminder that the abyss is never truly empty. But to reach its current girth, Sagittarius A star must once have eaten more greedily. Perhaps in the youth of the galaxy, when star birth ran rampant, the center was a banquet. Or perhaps the whole was born already massive, collapsing from primordial clouds that had not yet learned to make stars. The answer lies hidden in the way ancient stars orbit today, fossils carrying the imprint of long-vanished mass. We read these fossils the way geologists read layers of stone. There are other mysteries. We have detected filaments of radio emission, vertical stripes rising from the galactic plane like harp strings tens of light years long. No one knows what plucks them. We have seen a gas cloud named G2 survive an encounter that should have torn it apart, as though something unseen cushioned it. We have measured magnetic fields aligned like ranks of soldiers, guiding particles to energies far higher than any earthly accelerator. Cosmic rays, atomic nuclei stripped of electrons, race outward at nearly the speed of light. Some may reach Earth after a journey lasting 100 centuries, a whisper from the center brushed across our atmosphere. When you stand beneath the aurora, a few of the shimmering arcs are lit by particles born in the Milky Way's heart. And what of time near the black hole? If you dared to hover just outside the last stable orbit, your heartbeat would slow against the pull. A year of your life would equal centuries on Earth. You would watch the galaxy spin like a great wheel, new civilizations rise and fall in the blink of an eye. Yet to you, your pulse would feel steady. Reality is local, Einstein said. Gravity bends more than light, it bends duration itself. The center is not merely a place, it is a deeper now. We cannot send probes. Even if we could build a vessel that surfed light itself, the trip would last longer than recorded history. Instead, we send photons and radio waves, ghost messengers that travel undisturbed. They pass through dust that once blocked every telescope, because the dust is transparent to their long wavelengths. We stitch their faint echoes into images sharper than sight. In those images, we see shadows cast by gas falling toward darkness, and we see the shadows move year by year, frame by frame, like the slow hands of a cosmic clock. Each observation is a time capsule, a photograph not of how the center is, but of how it was when light began its journey in the age of mammoths, or the age of iron, or the age of steam. We assemble these moments into cinema, and the black hole awakens in our minds. What would it feel like to stand on a planet orbiting one of the central cluster stars? The night side would glow ruby and violet from nebulae compressed by stellar winds. Shooting stars would not be sand grains, but suns flung too close and torn apart. Gravity would pull tides across the crust, raising mountains that migrate once every few hours. Life, if it could exist, would need to anchor itself deep underground, drawing energy not from a friendly star, but from the chemical breath of rock. Such life would never see the sky, yet it might sense, through subtle tremors, the rhythm of the black hole's meals. It might evolve to read the pulse of flares as monks read bells calling them to prayer. We are not the only possible witnesses. And still, the black hole is small beside its own galaxy. 4 million suns sounds vast, yet the Milky Way holds 400 billion. Sagittarius A star is a seed, not the soil. Its gravity rules only the inner few parsecs. Beyond that, the spiral arms answer more to their own collective mass than to any single tyrant. But seeds shape forests. Without the stability provided by a central anchor, galaxies might scatter into drifting islands of stars. The black hole is the still point around which the whole luminous storm revolves. Remove it, and over billions of years the center would loosen, stars dispersing like dancers when the music fades. We owe our ordered sky to an absence. We speak of mysteries, yet every mystery is a doorway. We do not know how black holes grow so quickly in the early universe, nor how they stop growing so modestly today. We do not know what shapes the bar, nor why some galaxies host twin hearts instead of one. We do not know what happens inside the horizon, where words like up and down lose meaning. But the questions themselves illuminate us. They remind us that knowledge is not a tower to be completed, but a horizon that recedes as we approach. Each answer breeds new instruments, and each instrument breeds new skies. Perhaps in another million years, a civilization nearer the bulge will launch telescopes that ride gravitational waves like ships on a tide. They will map the shadow of the black hole in real time, watch stars plunge and emerge, and read the ripples as easily as we read weather. They may chart safe corridors through radiation, thread probes between magnetic lines, and send poetry encoded in neutrino bursts to alert their descendants that the abyss is not to be feared, but understood. We, on our distant rim, can only watch and wonder, content to be early explorers of a continent whose mountains we will never climb. Yet even from here, the center touches us. The iron in your blood, the calcium in your bones, the gold in the ring on your finger, all were forged in stars that lived and died before Earth existed. Some of those stars were born near the bulge, flung outward by gravitational slingshots, carrying heavy elements to the quiet suburbs where the sun would later form. We are not merely observers of the Milky Way's heart. We are its scattered children, assembled from dust that once circled the black hole like moths around a flame. So when you next see the Milky Way arched across summer skies, remember the invisible anchor below the tail of Scorpius. A region where space falls forever inward, where stars race like toy boats on a whirlpool, where time and light are bent to breaking. A place silent and dark, yet around which the whole bright pageant turns. And remember that every heartbeat, every thought, every glance upward is part of the same slow turning. We live on a fragile ripple far from the depths, yet the depths live quietly within us. Somewhere beyond the dust, the next star is already beginning its inward spiral. In a few million years it will flare, and the black hole will gain a grain more mass. The galaxy will adjust its balance by the width of a breath, and the spiral arms will continue their stately waltz. Nothing ends, everything moves. And we, with our brief lives and patient telescopes, are the universe learning how to look back at itself, wondering what it will see when the lights dim and the long night begins. From the vantage point of a quiet world, it is easy to believe the galaxy ends where the bright band of the Milky Way fades above the horizon. Yet that curtain of light is only the innermost echo of something far larger, something that does not blaze, something that does not conveniently announce its presence. Beyond the spiral arms, beyond the last visible stars, the galaxy continues outward in a slow dilution of suns until the very concept of edge dissolves into darkness. Imagine leaving the downtown of a glowing city and walking past the last street lamp. The pavement continues, the air remains, but the evidence of habitation thins until only the faintest footprints remain in the dust. In such a realm, a single star may drift alone through hundreds of cubic light years, yet it is still tethered, still gravitationally embraced by the galaxy we thought we knew. This outer province is called the halo, a name that belies its scale. If the bright disk where we live were scaled to the width of a dinner plate, the halo would swell to a ghostly sphere wider than a basketball court. Its radius stretches 300,000 light years, a distance so gratuitous that a signal traveling since the first vertebrates crawled onto land would still be racing outward through the emptiness, not yet having reached the presumed boundary. Inside this sphere, stars are rare but not absent. They arrive in loose streams, the shredded remnants of dwarf galaxies that wandered too close and were pulled apart like cosmic taffy. These stars carry with them the chemical fingerprints of places that no longer exist, fossil ink in the margins of a book whose pages were torn out long ago. Traveling with them are the globular clusters, compact cities of 1,000,000 suns packed into a volume hardly wider than the distance from our sun to its nearest neighbor. There are roughly 150 of these clusters sprinkled through the halo, each as old as the galaxy itself, each orbiting the center on paths tilted at reckless angles to the orderly disk. From within, their skies must be spectacular. No night, only a continuous blaze of colored suns sliding across the heavens. From out here in the dark between, they appear as faint cotton balls in backyard telescopes, yet they are the anchor points that betray the presence of something still more elusive. For the clusters move too fast, so do the lone stars. So, in fact, does every tracer of mass that astronomers have measured in the outermost reaches. The velocity should drop as distance increases, the way Neptune plods more slowly around the Sun than Mercury does. Instead, the rotation curve stays flat, a stubborn plateau that extends far beyond the place where the luminous galaxy ends. Something unseen rides with the visible, an invisible current that keeps the outskirts from drifting away. To account for the measured speeds, the galaxy must contain 10 times more mass than the combined total of every star, every planet, every puff of gas, every drifting mote of dust. Whatever this extra substance is, it neither emits nor absorbs light. It passes through our instruments like a silent wind, and so we call it dark matter. Dark matter is not merely a vacancy where light is missing. It is a presence, a scaffolding whose gravity molds the architecture of the visible. Simulations that begin with a uniform sea of particles, ruled only by gravity and the gentle density ripples laid down in the first instance after the Big Bang, evolve into a web of filaments, knots, and voids that mirror the observed universe. Within this cosmic web, the halo of our galaxy sits at the intersection of thinner strands, a node where dark matter pooled and condensed until it formed a vast, roughly spherical envelope. The particles, if particles they are, swarm through one another like ghosts, never colliding, only bending space so that ordinary matter finds itself drawn inward, compressed, coaxed into forming stars, then spiral patterns, then the illusion that luminous matter is the protagonist of the story. Yet we are, in mass at least, only the frosting. Take all the living things that have ever breathed, all the mountains, all the oceans of every world, all the suns that warm them, and you still stand on the shore of an ocean whose depths you will never see. The dark envelope extends far beyond the orbit of the Magellanic Clouds, two dwarf galaxies that themselves are barely holding onto their stars as the Milky Way's gravity strips them away. It may reach twice the distance we currently chart, perhaps more. There is no natural border where the galaxy's influence ends and the smooth expansion of the universe begins. There is only a gradual thinning, a place where the words inside and outside lose their meaning. Some of the halo's stars have been discovered by accident, caught in surveys that hunted for something else entirely. They betray themselves through motion. While most nearby stars drift gently across the sky, these strangers streak like jets at altitude, their trajectories bending only slightly as they fall through the gravitational well and climb back out again. Each such star is a messenger, a test particle whose orbit traces the shape of the invisible. By mapping enough of them, astronomers reconstruct the gravitational field and therefore the distribution of mass, both seen and unseen. The result is a ghostly contour map, lines of equal gravity wrapping the galaxy like the rings of a tree, each ring encoding events we have yet to decipher. Occasionally, one of these halo suns nears the end of its journey, exhausting its thermonuclear patience, and collapsing in a supernova whose light reaches us as a solitary flash in an apparently empty patch of sky. Such explosions, seen once every few centuries, illuminate the surrounding darkness for a few weeks, betraying the presence of tenuous gas that had been invisible before. The gas turns out to be enriched with heavy elements, iron, nickel, zinc, evidence that even here in the loneliest provinces, cycles of birth and death have proceeded for billions of years. The halo is not a desert. It is an archive, a slow-motion library where the history of the galaxy is written in sparse, luminous ink. Still, the greater mystery remains. Dark matter has not yet been persuaded to reveal itself in any terrestrial experiment. Underground detectors, buried deep in caverns to shield against the chatter of ordinary particles, wait for the gentle kick of a passing wisp. Particle colliders recreate energies last seen fractions of a second after the Big Bang, hoping to summon the phantom into a momentary existence. So far, the screens stay blank. The only evidence is gravitational, and gravity, patient and indiscriminate, refuses to name its source. Perhaps the unseen is composed of particles so light and so numerous that their individual impacts are below any threshold we can measure. Perhaps it is a field, a curvature in spacetime itself, a relic of forces that operated in the first heartbeat of creation. Perhaps our categories, particle, wave, field, are merely the vocabulary of a creature that evolved to count fruit and track seasons, inadequate for describing what fills the night. What seems certain is that the halo we see, the sparse stars, the globular clusters, the wisps of torn galaxies, is only the luminous foam on a deeper tide. Beyond the last measured orbit, the dark envelope merges into the filaments of the cosmic web, threads of invisible matter that stretch between clusters of galaxies, holding the universe itself in a delicate scaffolding. If we could see with eyes tuned to gravity rather than light, the sky would be unrecognizable. No stars, only shimmering lines of force, whirlpools where galaxies spin, and vast currents flowing toward distant attractors whose names we have not yet spoken. In this grander geography, our galaxy is not an island but a promontory, a peninsula attached to something continent-sized in the dark. The local group, our collection of two large spirals and dozens of smaller companions, rides such a filament, drifting toward a node where other filaments converge, a region astronomers have named the Great Attractor. The motion is gentle, a few hundred kilometers per second, the pace of continents on Earth. Yet over billions of years it reshapes the map, pulling entire clusters into new arrangements, rewriting the destinations of every star we see. Contemplating this, we might feel diminished, our lives reduced to a flicker within a flicker. But consider the alternative, A cosmos small enough to be mastered would also be too small to surprise. The halo reminds us that knowledge is not a container to be filled, but a horizon that recedes as we approach. Each star we map, each orbit we measure, each silent particle we fail to detect is a step in an unending conversation between what we are and what surrounds us. There is comfort in the immensity, a liberation in discovering that the story is larger than any single telling. And so, out in the darkness, the galaxy continues to gather its invisible cloak around it, drawing the future toward a center that will never be still. We, along with every atom that has ever worn the name Earth, move within that current, passengers on a raft of stars whose full extent we may never chart. The night sky, quiet above our rooftops, is not a ceiling but a shoreline. Beyond it, the dark ocean calls, and we have only begun to listen for the waves. Imagine the Milky Way as a slow-spinning storm of stars. From a distance, its spiral arms would look like soft brushstrokes of light, each one a lane of gas, dust, and countless suns, all trailing behind as the galaxy turns. We live inside one of those brushstrokes, a modest ribbon known to astronomers as the Orion Cygnus arm, though we often call it simply the local arm. It is not the grandest arm, nor the most brilliant, yet it is the one that holds every sky we have ever named, every story we have ever told beneath the night. To find ourselves within it, we must first let go of the instinct to stand outside and look in. There is no balcony above the galaxy where we can lean on the railing and admire the view. Instead, we ride the arm itself, circling the galactic center at 500,000 kilometers each hour, a speed so swift that a journey equal to Earth's entire age would still carry us only halfway round. In the map of a spiral, we are mid-stride between two brighter arms, the Perseus farther out toward the edge and the Sagittarius closer to the crowded core. Our arm is thinner, more delicate, a tendril only a few hundred light years across, meandering outward with a gentle twist, like a ribbon loosened from a gift. If you could pause the rotation and drift above the disk, you might see the arms as frozen waves. The pitch of each wave, how tightly it wraps the center, reveals the character of the region. Our local arm lies at a shallow angle, a relaxed spiral that never quite hugs the bulge, never quite straightens into space. Between these waves, the stars thin out, the gas grows colder, and the night becomes quieter. Inside the waves, the medium glows, compressed by its own passage through the galactic plane, birthing new suns that ignite like sparks behind a grindstone. One such spark, only 1,300 light-years away, is the Orion Nebula. On winter evenings, it hangs below Orion's belt, a hazy blossom to the unaided eye. Through a telescope, its petals unfold into rose-tinted gas, where infant suns heat their cocoons and stellar winds sculpt luminous caverns. The nebula is merely the brightest blister along the arm. There are dozens more, some hidden behind dust, others glowing in infrared grandeur. Together they mark the arm as a place where creation is still underway, where the galaxy has not yet finished adding to its census of stars. Yet the arm is more than a nursery. It is also a corridor of destruction and renewal. 4.5 billion years ago, when the sun itself was coalescing, the region around it was littered with the debris of earlier generations, ashes of massive stars that had burst as supernovae, seeding space with iron, silicon, gold. That debris compressed into a rotating cloud, a whisper of gas scarcely denser than the vacuum it inhabited, but vast enough to span hundreds of trillions of kilometers. Gravity eased it inward, the cloud spun faster, flattened, and from its center ignited our modest star. Even today, the arm remembers such explosions. Shock waves ripple through the medium, squeezing fresh knots of gas until they glow as protostars, continuing the ancient cycle. While the galaxy turns, the sun does not sit placidly in one spot. It oscillates up and down through the plane, like a horse on a carousel rising and falling, completing one vertical journey every 60 million years. We are, at present, slightly north of the mid-plane, ascending toward a thin mist of clouds that astronomers call the local fluff. Beyond that lies emptier space, the local bubble, a cavity hundreds of light-years wide, blown clear by supernovae that detonated when dinosaurs still walked Earth. The bubble's walls are soft and porous. Beyond them, the denser arm resumes. Our solar system is a small fish in a quiet lagoon, occasionally brushing the reeds of denser clouds, feeling the distant surge of tides from the spiral wave. To picture the arm's breadth, consider light itself. A beam from the sun takes 8 minutes to reach us, 4 years to reach the next star, but nearly a millennium to cross from one edge of the local arm to the other. Yet this is only a filament in the grand tapestry. The Perseus arm, the next major wave outward, lies twice that distance again, its far side so remote that a radio greeting sent today would still be en route when today's newborns reach old age. Between us and Perseus drift scattered ensembles of young stars, orphaned clusters torn free by gravity's subtle tug, stellar castaways adrift in the fainter spaces between the arms. Travel inward and you meet the Sagittarius arm, richer in gas, brighter in newborn giants, more tightly wrapped around the galaxy's heart. There, starbirth is fervent, almost frantic, fed by streams of gas that pour along the bar at the very center and fan outward like water from a rotating sprinkler. From our vantage, the Sagittarius arm is a river of milk beyond the constellation of its name, its clouds of stars set like pearls on a hidden string. We circle that same center, yet our path is calmer, our arm less crowded, a suburban lane compared to the bustling downtown lanes of Sagittarius. Still, even suburbia changes. As the sun orbits, the arm itself is not a rigid structure but a pattern that slides through the stars, a wave of density that moves slower than the stars themselves. We overtake it, then recede, like a cyclist pedaling through a standing wave in a stream. Over millions of years, the sky will rearrange itself. Orion will drift apart. New constellations will assemble from stars that today lie scattered. The nebulae we know will have dispersed, their gases thinned until they merge with the background, while new clouds gather, new nurseries ignite, and future skies blaze with unfamiliar suns. Pause and let the scales settle. Every atom in our bodies was once part of that arm, cooked in stellar furnaces, flung outward by explosions, caught again in the gravity of a nascent planet. We are not mere observers of the spiral. We are its constituents, brief flickers of awareness riding a wave that has rolled for billions of years. The arm does not notice us, yet it carries us, the way a tide carries a glint of moonlight on its back, unnoticed by the ocean yet inseparable from the surge. What lies ahead along this path? Ahead, the Perseus arm waits with its own nebulae, its own clusters, perhaps other worlds where other minds might one day look outward and wonder. Behind, the Sagittarius arm recedes, its brilliant nurseries folding into the past. We drift between them in a quiet reach neither bustling nor empty, a corridor where the night is dark enough to think, yet bright enough to dream. Somewhere ahead, the arms tighten, the stars crowd, and the glow at the galaxy's heart swells into a blaze of billions of suns. There orbits a darkness vast enough to swallow star streams whole, yet invisible to eyes that evolved beneath gentle skies. Toward that center, every arm is swept, including our own. And as we go, we carry with us the record of where we have traveled, etched into the chemical memories of meteorites, of planets, of the very air we breathe. Imagine a single photon of light born at the far edge of the Milky Way. It has no mass, no rest, no weariness. It sets out across the starlit disk at the one speed the cosmos allows itself. For 100,000 earthly years it glides above spiral arms that slowly braid and unbraid. Planets form, oceans condense, creatures crawl, speak, vanish. Still the photon travels. When at last it reaches the opposite rim, the galaxy has turned only a fraction of a degree, yet whole civilizations have forgotten they ever existed. That is how wide our home galaxy is when translated into the language of light. Now translate it into the language of footsteps. If you could walk 1 meter every second under a dark sky, you would need to keep walking without sleep for 300 million years to cover the same span. By then, the continents you knew would have merged and split twice over. Your footprints would be fossil, then molten, then vapor. Distance, when spoken in light or in footsteps, becomes time. We live inside a structure so vast that even its own radius must be measured in generations of species, not in kilometers. Hold that thought and shrink the scale. Consider not the whole wheel of stars, but one grain of dust caught in its rim, our sun. Once every 250 billion Earth years, it completes a single orbit around the galactic center. The last time we were in this patch of the spiral, dinosaurs had not yet appeared. The continents were in unfamiliar places. A full galactic year is so long that the mountain chains we call eternal have risen and crumbled twice within it. Yet to the galaxy itself, the sun has moved only once around its slow, eternal waltz, a quiet partner that remembers every step but will never repeat a single one. Inside that dance, the stars are not fixed decorations. They migrate. Born in crowded nurseries, they scatter along the spiral arms, some drifting inward toward the bright core, others outward to the lonely halo. Over millions of years, a star can trade its birthplace for a neighborhood where no sibling of its birth cluster ever treads. The sun itself has wandered. 4 billion years ago, it formed in a modest clutch of a few thousand stars. Today, every one of those siblings has been strewn so far that we pass most of them without recognition. We are, in a sense, galactic orphans, making our way around the center with strangers who share no memory of our cradle. This drift is subtle, yet relentless. A star may move only a few kilometers every second, no faster than a commercial airliner. But given 10 million centuries, it can trade the inner bright lights of the core for the ghostly outskirts where the Milky Way's halo meets the emptiness between galaxies. Such stately currents stir the spiral like cream in coffee until the original pattern is lost. We see only a snapshot, a single frame of a film billions of years long. From that single frame, we piece together the plot, guessing at the opening scene and the final credits. What then of the sun's future path? We are currently halfway out, in a thin branch of a spur between two major arms. Ahead of us lie 25 more galactic years before the sun's nuclear furnace dims. Each orbit will nudge us slightly inward or outward, depending on the gravitational tides of passing molecular clouds. In 4 orbits, we will likely drift a few thousand light-years closer to the bar-shaped heart. Whether planets survive that slow migration depends less on the drift itself than on the neighborhood we pass through. Dense clouds of gas can perturb the icy vestiges beyond Neptune, flinging comets sunward. Nearby supernovae can erode the outer layers of atmospheres. Yet the same migration also stirs the raw material for new worlds. Without the radial mixing that spread heavy elements across the disk, Earth's rocky foundation would never have formed. What endangers also enables. Consider the mind-bending calm of these time scales. A human heart beats once every second. Civilizations rise and fall in a few million such beats. Yet the galaxy measures its affairs in heartbeats of a different order, one beat every 250 billion years. We live within that slow pulse, Mayfly-quick, unaware of the systole and diastole of spiral arms. Our instruments can map the flow, but our bodies can never feel it. We are like bacteria on a floating log, guessing at ocean currents. Still, the log is drifting. The Andromeda Galaxy, twice our diameter, is falling toward us through the cold intergalactic dark. In 4 billion years, its outskirts will brush ours, and the two great wheels will begin to fuse. By then, the sun will be only halfway through another galactic year. Earth's oceans, if they still exist, will have boiled once and frozen twice. The slow grinding of planetary orbits may already have shifted us too close or too far from the sun. Yet even if life here ends, the Milky Way's stately clock will tick on, indifferent. Another spiral arm will form. Other suns will migrate. Other minds, on worlds we will never know, may one day look up and wonder at the same river of light. We began with a single photon crossing the starlit plane. We end with a single thought crossing the mind. Time, not space, is the final currency of the cosmos. Distance is only the price paid in moments. A galaxy is not a place. It is a story still being told, a tale so long that even its characters forget their lines. Yet within that forgetting lies a strange mercy. Because we are brief, we can stand beneath the summer sky and feel the grandeur without despair. Because we are small, the slow turning of the Milky Way becomes not a prison but a harbor, a rhythm against which the brief flare of consciousness is all the more precious. Hold that feeling gently, for it will guide us when we step beyond the disk and ask how our island of stars drifts within the cosmic sea of galaxies. Imagine cupping a single snowflake in your palm. For an instant you see its delicate symmetry, the faint sparkle, the way it lands between the lines of your skin. Then it vanishes, leaving only the memory of something fragile and perfect. Galaxies, too, arrive in countless shapes, yet we rarely pause to notice how each one is sculpted by gravity and time. Tonight we step back from the Milky Way just far enough to see the full gallery of forms into which stars gather, and we ask where our home fits among them. Begin with the smallest. Dwarf spheroidals drift like ghostly lanterns around our own galaxy, so diffuse that even their brightest stars feel lonely. 100,000 suns may live inside, yet the whole cluster glows with the luminosity of a single modest giant star. If the Earth were scaled to a grain of sand, these dwarfs would be misty clouds the size of a room. Their outermost suns, so widely spaced that darkness between them outweighs light. They are the quiet children of the cosmic family, ancient and content to orbit in silence, waiting for the slow pull of the Milky Way to unravel them across the eons. At the opposite extreme stand the giant ellipticals. Some swell to diameters of 2 million light-years, each one a city of hundreds of trillions of stars. Within them, suns press so close that night skies would never grow fully dark. A resident planet might bask in the perpetual amber twilight of neighboring suns. Yet these magnificent swarms are not nurseries. Their gas was spent long ago in bursts of furious creation, leaving behind aged crimson stars that trace graceful, stretched orbits like dancers gliding across a dark stage. They are cathedrals of starlight, echoing with the memory of formation finished. Between the ghosts and the cathedrals, spirals like our own occupy a middle ground. A typical spiral galaxy carries the mass of 100 billion suns, though most of that mass is invisible, bound in halos of dark matter that never gleam. The Milky Way lies near the center of this range, neither lightweight nor titanic. Place a pea on a dinner plate. That is the relative proportion of luminous matter to the dark sphere that cradles it. We live inside the bright dot, mistaking it for the whole. Sizes follow a similar modesty. Measure the Milky Way's star-rich disk edge to edge, and you would spend 100,000 years crossing it at light speed. Impressive, until you learn that the wings of the largest spirals span twice that distance, while the smallest dwarfs could fit between Earth and the nearest star with room to spare. Scale in the universe is a spectrum without prejudice. Each galaxy simply gathers what gravity allows. Edwin Hubble captured this variety in a simple diagram, a tuning fork of shapes that still guides astronomers today. Ellipticals rest on the handle, their roundness increasing toward the weighty end. Tines branch into spirals, first those with tightly wrapped arms, then those with arms relaxed and sprawling. At the fork's junction lie the lenticulars, galaxies caught between, their disks smooth, their star formation spent. The Milky Way sits along the tine labeled SB, an intermediate spiral whose arms are neither pinched nor flung wide. Average, in other words, a cosmic middle child, but averages can be misleading. Average temperatures on Earth are pleasant, yet deserts and polar seas still scorch and freeze. Similarly, the Milky Way's star factories are prolific. Every year a handful of new suns ignite along its spiral arms, a rate higher than in many similar galaxies. Its central black hole, though quiet now, may have quasared in the distant past, shining brighter than the rest of the galaxy combined. Even an ordinary spiral can, under the right conditions, behave in extraordinary ways. Still, the universe rarely lets its creations remain unchanged. 2.5 million light-years away, the Andromeda galaxy glides toward us, a spiral slightly larger, slightly more massive, its arms tinted with the blush of fresh star birth. Every second the gap closes by 100 kilometers, a speed that would carry it from the Earth to the Moon in little more than an hour. Yet the distances are so vast that the final embrace lies 4 billion years ahead. Imagine two great musical discs sliding one through the other, their strings of stars passing, tugging, looping, until gravity weaves a single new structure. The merger will not be a collision in the terrestrial sense. Stars are spaced too widely for head-on crashes. Instead, gravity will sculpt arcs and tails, a firework display frozen in time, before relaxing into an enormous, aging elliptical galaxy some have already nicknamed Milkomeda. During that slow dance, our sun will be nearing the end of its steady middle age. Earth, if it still harbors observers, will orbit within a sky no longer banded by the Milky Way's river of light, but wrapped instead in a glowing halo of newly mingled stars. The constellations we know will have scattered, their patterns erased by the gravitational tides of two galaxies learning to share one future. Until then, we have the privilege of living inside a relatively stable spiral, a halfway house between the quiet dwarfs and the roaring giants. We can study the full symphony because we stand near its center seat, able to hear both the piccolo trill of small galaxies and the tuba boom of the massive. From this perch, we learn that galaxies are not isolated artworks but members of a dynamic ecosystem. They cannibalize the small, merge with the large, convert gas to stars and stars to heavy elements, then expel those elements back into the void to seed the next generation. Our very existence relies on this cosmic recycling. The calcium in our bones, the iron in our blood, were forged in stars that lived and died before the sun was born. Some within galaxies we shall never identify, others inside the Milky Way's own spiral arms. Each of us carries atoms that once danced in the core of a red giant, or shimmered in the blast wave of a supernova whose light briefly outshone an entire galaxy. We are not simply in the universe, we are of it, down to the last mote. Tonight, as you step outside and gaze upward, remember that the soft river of light overhead is a disk of hundreds of billions of suns, itself adrift in a sea of other configurations, each as real and as vast as your own. Somewhere in that ocean, beings we can barely imagine may be looking back, comparing their island universe to the faint smudge that will one day be our home. And though we stand separated by incomprehensible distances, we share the same cosmic heritage. Gravity sculpting light, time sculpting matter, the perpetual unfolding of the possible. The story does not end with comparison. To understand scale is to prepare for deeper questions. How did the very first galaxies ignite from darkness? What forces seeded the seeds of their structure? We turn next to the earliest epochs, to a time before stars, to the birth of the galaxies themselves. The Milky Way is not a lonely monarch. It drifts through darkness in quiet company, a silver fish among others in a slow, starlit current. If we could step outside our spiral arms and look back, we would first notice the dim lanterns of two small galaxies locked to us by gravity's invisible threads. The large and small Magellanic Clouds are not true satellites, but passing travelers caught for the moment in our gravitational net, their shapes warped by tides of dark matter we cannot see. Together with a few dozen fainter dwarfs, ghostly smudges whose ancient suns barely outnumber the people of a modest town, we form a fragile association called the local group. Its entire span is a mere 3 million light-years across, small enough that light itself could cross it in the time our planet has known trees and flowers. Hold that scale in mind, 3 million light-years. On Earth, a single heartbeat lasts 1 second. Let each second stand for 1,000 years. Count them until you reach 50 weeks of unbroken ticking and you have crossed the local group. A long breath in cosmic terms, yet only the first step outward. Beyond this gentle neighborhood, the gravity of our galaxy mingles with that of Andromeda, the only other giant in our group. The two spirals are falling together at the pace a fingernail grows, destined to merge in 4 billion years. When they do, the local group will settle into a single amorphous cloud of stars, its identity dissolved like sugar in warm water. On the cosmic clock, this merger is a blink, yet it will be the last major event our lineage ever witnesses from this corner of space. Past Andromeda, the next landmarks are not galaxies but clusters of galaxies, each a swarm of hundreds or thousands swaddled in hot gas and the unseen scaffolding of dark matter. The nearest of these great congregations is the Virgo cluster, whose heart lies 60 million light-years away. Imagine every star in the Milky Way as a single grain of sand. To fill a sphere the size of the Virgo cluster, you would need enough sand to blanket every beach and desert on Earth, then repeat the exercise on 100 planets. Even so, Virgo is only one node in a still larger architecture. For decades, we drew maps that placed the local group on the outskirts of the Virgo supercluster, a flattened cloud of galaxies whose gravitational tides seem to define our motion. But recent measurements of peculiar velocities, tiny deviations from the uniform expansion of space, revealed a more sprawling structure. We belong not to Virgo alone, but to Laniakea, a Hawaiian word meaning immense heaven. Laniakea is not a tight cluster but a loose, flowing river of matter more than 500 million light-years across. Within it, galaxies slide like leaves on a dark current toward a hidden whirlpool. The Great Attractor, a region of enhanced density whose gravity bends our paths. Picture Laniakea as a continent made of starlight, its shores lapped by colder voids. If you traveled at the speed of light, it would still take you 500 centuries to cross from one edge to the other. Yet even this continent is only an island in a still vaster ocean. Beyond Laniakea, the cosmic web begins. Filaments of galaxies stretch across billions of light-years, threading empty regions called voids, where only a handful of lonely galaxies drift. The web is not static, it grows. Where filaments intersect, clusters collapse and new galaxies are still being born. We see these intersections as they were when the universe was younger, their light journeying toward us across stretches of time that dwarf the entire saga of life on Earth. How far can we see? The answer is set by the age of the universe itself. Light travels for 13.8 billion years before reaching us from the most distant sources. But space has expanded during the journey, stretching the road those photons traveled. Today, the most remote visible objects are 46 billion light-years away, a horizon that defines the observable universe. Beyond this sphere lies more of the same, perhaps forever hidden by the finite speed of light and the accelerating expansion of space. Let us return to the Milky Way. Within this vast bubble, 46 billion light-years in radius, There are roughly 2 trillion galaxies. If every galaxy were a single drop of water, all the oceans on Earth would hold barely a tenth of them. Our own spiral occupies 1/2 trillionth of that volume, a proportion so small that words falter. Yet here we are, on a rocky planet orbiting an ordinary star, able to weigh the universe and taste its age. Consider a single grain of salt. Let it represent the Milky Way. Place it on a vast plain that stretches from horizon to horizon. The plain is the observable universe, and every other grain you would need to scatter across it to match the density of galaxies would cover the land in a sparse frost, each crystal separated from its nearest neighbor by the length of a continent. Most of the plain is empty. Most of everything is darkness. Why then does the night sky glow at all? Because light, though swift, is patient. The photons that left the first galaxies have traveled through expanding space for longer than Earth has existed, arriving only now to be caught by mirrors of glass and aluminum perched on mountaintops. Each image is a postage stamp from a place that may no longer exist, a reminder that the universe we see is a scrapbook of ghosts. We do not know how much more lies beyond the horizon. Inflationary theory, born from the gentle ripples in the cosmic microwave background, suggests that the entire observable universe is only a patch in a quilt that could stretch to infinity. If so, then somewhere beyond our sight, other Milky Ways may be rising, their citizens, should they exist, asking the same questions under the same scattered constellations. Repetition becomes probable when the canvas is endless, yet distance isolates every island of light so completely that contact may be impossible. The sky is not a ceiling, it is a shoreline. Pause and feel the strangeness. Every person you have ever loved, every story that has ever quickened your pulse, spins on a planet that occupies 1 part in 10 to the power of 61 of the observable volume. We are not central to any cosmic drama, yet we are the part of the universe that can notice itself. Out in the dark between the filaments, where galaxies thin to a mere mist, the expansion of space accelerates. Nothing we know can reverse it. In 100 billion years, an observer within some future galaxy will see only emptiness in every direction, the remaining stars locked into islands that have drifted beyond each other's reach. They will measure the cosmos and conclude, wrongly, that their galaxy is alone. We are fortunate to live while the sky is still crowded with evidence of company. So, what is the Milky Way within this grand tapestry? A single thread in a carpet too vast to ever fully unfold. Yet tugging on that thread reveals the entire weave. By mapping the motion of our nearest neighbors, we discovered Laniakea. By charting the faint microwave afterglow, we dated the universe. By counting galaxies across the sky, we learned that most of matter is dark, and that space itself contains an energy that refuses to sit still. One small galaxy, generously examined, has become our window on everything. The journey outward is also a journey inward. Each step that dwarfs our home also affirms its rarity. A planet where skies are clear enough to see distant galaxies, where minds are curious enough to measure them, is itself a fragile filament in the web. We are the moving part of the cosmos that can wonder, and perhaps that is enough. Soon we will turn our gaze back toward the interior, toward the dense heart of the Milky Way, where a quiet monster waits behind curtains of dust. There, gravity has pooled so deeply that not even light can climb out. What we find at the center will teach us how galaxies are anchored, and how the smallest motions can steer the fate of hundreds of billions of stars. Imagine for a moment that we could shrink the entire Milky Way to the size of Earth. In that miniature sky, our sun would be a grain of sand, one among hundreds of billions, resting on a fingertip of spiral beach. Earth itself would be a bacterium clinging to that grain, and you and I would be subatomic ripples somewhere inside the bacterium's dreams. Yet from that invisible speck, we have measured the curvature of the galaxy, counted its stars, mapped its dust, and sent our questions riding on light beams into the dark. The mere fact that such measurement is possible feels, at first, like a miracle of ingenuity. But it also carries a chill, for the same yardstick that reveals our reach reveals our remoteness. Stand outside on the clearest night and the Milky Way appears as a delicate river of light, soft, almost close enough to scoop in your hands. The naked eye can perceive only a few thousand stars, an infinitesimal fraction of the whole. To them we give names, stories, constellations. The rest remain anonymous, lost in the haze. This haze is distance made visible, every photon a messenger that left its star before speech existed, before fire was tamed, before any foot walked the planet. The light arrives only to confess how long it has been traveling. We greet it with wonder, yet the very slenderness of that greeting exposes the boundaries of flesh and bone. Consider distance not in light years but in heartbeats. A healthy adult heart pulses about once per second. To reach the nearest star beyond the sun at that gentle, mortal tempo, you would need to count non-stop for 8 years, and still be only 4 light years from home. To tally your way to the galactic center would demand 1,000,000 years of uninterrupted beating. And to cross the full disk, from one edge of the spiral to the other, your heart would have to drum for 30 million years. By then, the continents will have rearranged themselves beyond recognition. Mountains the size of Everest will have risen and crumbled to dust a dozen times over. Yet the galaxy itself will have scarcely stirred, a slow-turning wheel whose rotation we will never witness in a human lifetime. Our fastest machines, the Voyagers we launched in the optimism of the 1970s, have slipped the heliopause and now glide through the interstellar night. They travel at better than 60,000 kilometers per hour, faster than any other craft humans have thrown into darkness. Still, they would need 80,000 years to reach Proxima Centauri, a neighbor so close that, on the scale of the Milky Way, it is practically in our lap. 80 millennia is twice the length of recorded history. The engines that carried those craft were born of the same physics that powers ballistic missiles. They are marvelous, but they are not magic. No chemical flame, no gravitational slingshot, no planetary dance can squeeze human patience into the narrow corridor between stars. So engineers dream of sails pushed by starlight, of vast laser arrays focusing photons against silvered sheets thinner than soap bubbles. A craft no heavier than a postcard might, in theory, ride that pressure to 1/10 the speed of light, crossing the gap to Proxima in less than half a human lifetime. Others speak of fusion torches, miniature suns bottled in magnetic cages, or of antimatter engines whose exhaust is pure energy. Each concept balances on a cliff of unknown physics. Materials that do not yet exist, reactions we cannot yet sustain, costs measured in the gross domestic product of entire nations. Even if the engineering riddles were solved tomorrow, the human body remains fragile. Cosmic rays would sleep through the hull for decades. Micrometeoroids would pepper the ship like invisible bullets. And even at 1/10 of light speed, the galaxy's width is still a voyage of 1,000,000 years. The stars, it seems, are not far because we lack ambition. They are far because the universe is young and we are young within it. Yet distance is only half the story. The other half is time. Stars are not eternal. They are born, they burn, they exhale shells of gas, and they collapse into embers or black holes. The sun, midway through its 10-billion-year contract, will swell in another 5 billion years until Earth's oceans boil away. If consciousness persists, our descendants may witness the Andromeda galaxy filling half the sky, its spiral arms shredding our own in a slow, luminous collision. But that event lies 4 billion years ahead, an interval so vast that every human language ever spoken will have eroded to unrecognizable syllables, assuming anyone is still here to speak at all. The Milky Way, then, is not merely a place. It is a moment, a chapter in a book whose pages are turning too slowly for any one reader to finish. Cultural memory tries to tame this immensity through story. Indigenous traditions speak of the galaxy as a river where animals once crossed, or as a path for spirits walking home. Modern cities drown it in sodium glare, so that whole generations grow up having never seen the river overhead. We build observatories on remote mountaintops to recover what was once common knowledge, that we live on a small island of light adrift in an ocean larger than thought. The loss of the night sky is not simply an aesthetic misfortune. It is a forgetting of scale. When you can no longer see the edge, it becomes easy to believe there is no edge, easy to treat the planet as endless, the future as infinite, responsibility as optional. But responsibility is the quiet gift of perspective. Apollo's famous photograph of Earth rising above a barren horizon did not merely show a blue marble. It showed a sanctuary wrapped in the thinnest of veils, alone in a darkness that offers no mercy. The Milky Way, seen from Mars, would appear as a tilted band, slightly dimmer, slightly more alien, yet recognizably home. Step farther out, beyond Neptune, beyond the Oort cloud, and the Sun itself becomes just another star, Earth an undetectable mote. From there, the entire project of civilization, every love letter, every war, every cathedral and particle accelerator, occupies less than a pixel in the galactic archive. This might sound like a humiliation, but it is also a liberation. If our differences shrink to invisibility, so too do our excuses for hatred. We are, in the strictest sense, family embarked on a single voyage, passengers on a vessel whose life support system is exquisitely calibrated and heartbreakingly singular. Still, the mind resists. We evolve to recognize faces, to gauge the flight of a thrown stone, to fear the rustle in tall grass that might be a predator. The circuitry of the brain has no native port for a billion years. So we stitch the inconceivable to the familiar. A galaxy becomes a city of stars, its core a crowded downtown, its spiral arms sleepy suburbs. Yet the metaphor buckles under inspection. In a real city, you can walk from door to door in minutes. In this city, every neighbor is separated by lethal emptiness, and the sidewalks are frozen hydrogen drifting in perpetual twilight. Still, we speak because to speak is to reach, and to reach is human. Perhaps the deepest mystery is not how small we are, but that we are aware of being small. A neutron star does not feel lonely. A black hole does not wonder what it means to be. Only wet, fragile neurons knit the cosmos into narrative. In that sense, the galaxy is not merely out there. It is also in here, behind the eyes, in the chemical dusk of thought where hydrogen fusion becomes poetry. We are the universe's way of thinking about itself, a temporary constellation of carbon capable of calculating the lifetime of stars. The responsibility encoded in that sentence is staggering, because understanding implies choice. To know the fragility of worlds is to inherit the duty of protection, not because some external law demands it, but because no one else is present to shoulder the burden. So we plant telescopes like flowers in the high desert, their mirrors opening to the sky each dusk. We send radio whispers into the dark, not because we expect an answer tomorrow, but because conversation must begin somewhere. We archive seeds, languages, music, the color of sunrise over every ocean, in case the worst should come. These acts resemble prayer more than engineering, small gestures offered against the vast, indifferent night. Yet the night answers in its own language, with meteor showers that trace brief silver signatures across the black, with auroras that fold and unfold like ancient silk, with the slow wheel of the galaxy itself, a reminder that time is not simply loss but also becoming. One day, if the optimists are right, children may be born beneath a redder sun, on a world whose continents were never touched by terrestrial rain. They will learn to read by the light of two moons, and when they look up they will see the Milky Way as a tilted ring, unfamiliar yet strangely comforting. Perhaps they will send probes back toward the old planet, a blue dot near a yellow star, curious to see where the first questions arose. Or perhaps no such descendants will exist. Perhaps the story ends here with us, the only chapter ever written. We cannot know, and that ignorance, too, is part of the gift. Uncertainty keeps the future open, the way darkness keeps the sky open for light. What we can know is this: every atom in our bodies was forged in stellar furnaces that exploded before Earth was born. We are not simply inhabitants of the galaxy. We are memoranda written in starlight, brief notes that the universe has scribbled to itself. To forget the scale on which that note is written is to misread the handwriting. To remember it is to feel both the chill and the warmth of the cosmic ocean, the way a sailor feels the depth beneath the keel even while tasting salt on the breeze. The voyage is perilous, the shore is far, but the compass is conscience, and the map is drawn in acts of care. So let the night arrive, clear and moonless. Step outside until the porch light is behind you. Wait the 20 minutes it takes for the eye to uncover its ancient, star-sensitive self. Above, the river of light will reappear, quiet, unbowed. You will not see the black hole at the center, nor the radioactive shell expanding from a long-dead supernova, nor the icy comets falling silently toward stars you will never name. But you will see enough to remember that distance is not emptiness. It is room. Room for stories not yet imagined, for civilizations not yet fallen or risen, for love songs whose languages do not yet exist. And you will carry that memory back indoors, back to the daily scale of dishes, deadlines, doorbells, knowing that the small and the vast are not opposites but partners in the same dance. Somewhere else under another sun, another mind may be looking back across the same gulf, wondering who is out there. Between you and them lies the night, wide as time, bright with possibility. The conversation has already begun, spoken in the only language we truly share. The simple, astonishing fact that we are here to notice at all.